Hello everyone, welcome in this session about creating a Kubernetes operator within Java. So this is the high-level structure of the Kubernetes server. We have centrally that API server where also that kubectl command line tool interacts with, and those systems that works with the master, for instance, at the etcd for data storage, the DNS manager, etc. And at the end, the node will be launched containing your application in a container, and the end user can make use of that. So today we are going to concentrate on that API server, what you can do with it, how you can extend it so that you can use it for your own automation, for your own specific requirements. So I'm Rudy De Busscher. I'm working for Payara in the service team and as technical pre-sales. So I'm basically answering questions from customers and potential customers about the Payara platform in general. At the end of this session, I will foresee some time for questions. Keep them in mind and we can discuss them at the end. That will be easier because I'm doing screen share and not always seeing the questions. Quick look what we are going to cover today, and the beginning a few slides about a few definitions and concepts about Kubernetes itself. What is a Kubernetes operator? We have a quick look at that Java client that you have for Kubernetes API. But then within demos, we go much further and deeper, of course, to see how you can use it, how you can use that watcher principle to look for things going on within your Kubernetes cluster, how to create a custom resource, and how you can use that for your own automation. At the end, it's more or less a complete example, not entirely fully functional. There are a few parts missing, but you will see what the idea is and how you can use it for your own benefit. So the definition of Kubernetes, it is important that we have a quick look at it because you see there the words extensible, that Kubernetes is an extensible platform for managing container workloads, declarative and automation. So the Kubernetes platform is designed with that extensibility from day one. So you have those basic functionalities, querying or creating pods and services and deployments, etc. But that's just a basic functionality, and the idea is that you extend it for your own needs, for your own automation requirements in a declarative way. So declarative in this sentence means that you can define a YAML file. And sorry for those who really hate YAML, but we will see quite a lot of YAML today. And but based on that YAML file, you define there, you describe there what you need, and then the system will take care that it will evolve to a situation that that reflects that definition, that declarative description that you made there. Also in that Kubernetes, in the Kubernetes documentation, you have there the definition of an operator, although I don't find it very useful. It says something about method of packaging, deploying and managing a Kubernetes application. And an application then is an enterprise-ready containerized solution with pre-built deployment templates featuring portability. So that does not say anything what you can do with it and what is this supposed to solve. But you have to look at the Kubernetes operator like an operator that you have in any language, like in the Java language, you have the plus and the multiply. So the operator takes some input values, some source, and it transforms that to a result. That's also what the Kubernetes operator does. It takes that YAML file, that custom defined YAML file for your specific requirements, and transfer that to something which is usable within the Kubernetes platform, so that you can create pods and deployments and services, etc., based on that information. So if you see your operator like that, then it makes much more sense than the definition that I found. The Kubernetes API, the API server there at the center of the first picture that I showed you, is a very important one, because, as I said, the kubectl and the kubeadm commands uses those APIs, so everything goes through that API. And it is an HTTP-based one, so that's a very nice thing. REST-based, you can easily use that API server with curl commands, for instance, so you can query and manipulate the pods, config maps, events, etc. And since it is just an HTTP-based API, you can have a Java implementation that communicates with that API. And there are two currently that I'm aware of, which are important. And that's the first one is the official Java client created by the Kubernetes platform, Kubernetes project itself. But it seems that the Fabricate client is more popular, and so that's also the one that I used in this example, and I will use it in the demos. How can you make use of that API? Well, it is just an HTTP API, so you can just create a simple Java program with the main method, and you can call those endpoints, and you can perform the actions that you need. Nothing more is needed. You see several examples on internet. If you search for an operator in Java, they all require some additional frameworks. They say, oh yeah, you need to use injection and dependency stuff to get all your components together. Well, that's not needed. Just a plain Java program is enough. And even two simple lines can create your client. I've set them here also in the slides. We will see them in the example also. You have to just create a config object, and with that config object, you can pass it then to the client, and you have some Java instance which can connect to that API endpoints, and you can send commands to it, read the number of pods and the information which are currently running, for instance. Nothing more is needed. So that's the way that I'm going to use it in the examples, because that's also the most easiest way to understand what's going on and how you can use it. Later on, if you decide that you need such an operator, then of course you can create it with any kind of framework that you like, that you are familiar with. Also, an important aspect of that client API in Java or in general is that you have that watcher principle. You do not only query, for instance, state of the current active pods in the system, but you can also create a daemon thread that receives callbacks in the case there is any change on the number of pods. There is someone who is starting, someone who is stopped. Some of the pods, the data within the pods can change, for instance, the metadata. Then your watcher thread can get a callback for that and act upon those changes. For what is then an operator useful? I will show you one example. I can give you here another one. For instance, that you have created a system, an environment where your own customers can deploy some applications, some workloads on a Kubernetes that you manage. And by this watcher, for instance, you can see when a pod is created and stopped. And based on that, at the start and end time, you can calculate the amount for the invoice that based on the hours that that pod has been running. and you can send them the invoice for that use of that resource, that CPU, that memory, or whatever. That's one thing what you can do with such a watcher, because you get information when the instance is the pod is stopped and started. Let's have a demo where we can see this in action. Most of all of us are, I guess, developers, so we learn more by looking at the code than by looking at some slides. So as I mentioned, you just need a plain Java program. So I have created here a Maven project with a jar packaging file. And basically the only dependency that I need is that you need that Kubernetes client from Fabric 8. I'm also using something for the logging, for putting some message to the log to see what's going on. So that's why I have added here SLF4j and log4j, so that you easily can see, but you only need this Kubernetes client to get things started. That config, I mentioned that config builder. In principle, because most of the time you have installed already that Kubernetes client on your machine or in the environment that this will be running, or when this application is running within the Kubernetes cluster itself, which we will see later on, then you do not need to say anything about the configuration, because all the things are default or already defined. But with that config, you can define a lot of things like the default namespace that it is connecting to, some information about certificate files, username and password or tokens that you need to connect to the cluster, the timeouts that are defined, etc. So HTTP proxies. So there are a lot of things that you can define, but this simple default line is enough to get it working in your in most of the situations. And once you have that client, you can just ask, get me the version, the same as you would ask from the command line, the kubectl command, get the version if I type it correctly. You get some information. For instance, here you see that I'm still running 1.14 as Kubernetes, a little bit older one, but I'm not going to update it just before a presentation. If I run this program here, let me move this window from Zoom, then I can click my run of my program. I get the same information, but this time through that Java client, which is connecting then to that API server. This is, of course, just a basic test to see if everything works and it's easy to get things started. Let's go to a second example. And again, some windows of Zoom here are hindering me. Is that watch principle? Again, we start from that simple client, and then based on some commands, some methods defined on that client, we can get the list of pods. For instance, for client.pods.list gives us the list of all the pods which are running currently in the system. We can print out, for instance, the name of the pod, and then we see the same information as you see when you do get all command on the kubectl tool, for instance. But of course, more interesting is that you install a watcher on those pods. With this watch command, this starts up a daemon thread, and every time there is some change, as I mentioned already, in the Kubernetes cluster, this event received will be called. And then you get information about the type of action. Is it just an add, the addition of a pod, or modification, delete, etc. And then the entire pod information which is that available. So there is a lot of information there. You have the status, you have a lot of properties. There is even a superclass that metadata. So there comes a lot of information from the system to this method. Again, I'm just putting out the name in this case. And that's it. Again, simple example. We are running this program. And we see that the main thread prints out that there are currently 9 pods active in my system. I forgot to mention, but I'm using everything local here, and I'm working with Docker desktop. And there are 9 pods running in that system, all related to Kubernetes itself. For instance, that etcd system for storing all the data. But this watch command, as I said, starts up a separate thread, and immediately it receives also the information for those 9 same pods. So it's a bit like an event stream, your operator, because this is more or less some kind of operator already. It starts up and it receives all the information so that it can reconstruct the current situation of the cluster. So you get all the added events for each pod, containing all the current information for a pod each time. So it is a nice thing to get the information from that stream to reconstruct what's available, what is going on within the cluster at that time. So as an example, I'm going to add now, going to launch an additional pod by applying a deployment containing Payara Micro instance. And immediately you see that there is a pod created and some modifications. There are some data and metadata which are set immediately. And after that, after a few seconds, the state is ready. And then again, there is an update, and you will see that there is a new line coming in my log here. It takes a while. It was on purpose, but it takes now more time than I expected. There is a line. So this means if we could have a look into that data, which I did not print out for the moment, is that this pod is now fully functional and operational, running and ready for receiving requests. This is more or less the same information that you get here. The get all, you see that this pod is running with the same name. And if I delete it, I delete my deployment again. The first thing is that there are a few modifications posted there because the state is no longer active. It is in the state of shutting down. And eventually my pod is removed and I get the actual delete action as a callback in my example here. So that's are the basic principles of the Java client, how you can use that watcher principle. And that's then the basic for your operator, which is of course much more complex and a step further in using all those things. Try to do it step by step, but for those who are not aware of those things from custom resources, etc., it can be a bit of a fast ride through the rest of the presentation. So a custom resource is like defining something entirely new, like a pod or a service or a deployment. So it is on the same level, it's the same type of resource, but something that you have defined, something that you have the entire control of. But of course, if you create such, if you send information within the YAML about that type of object, it can only be understood by something that you have written, the Kubernetes operator in this case. So a custom YAML file which describes what you need. I give you an example in a minute. It describes what you need, and then that operator takes that information and performs the required actions like creating a deployment, executing commands against your instance which is started, etc., etc. And as the example, I'm going to take here the Payara clustering, for instance. You have the domain server, and then the actual application is deployed on two separate instances, who are running within a deployment group. That is a type of cluster that we have. There should be a load balancer in front so that your end user can access your application. And the creation of this domain, the domain server, the DAS server, the two instances, the load balancer, etc., all that can be done by that Kubernetes operator, so that you do not need to execute all those commands individually and create a separate deployment for the DAS servers, a separate one for the instances, etc., etc. So that's the automation part, what I was talking in the beginning. So how does it look like? First, I'm going to do it in two steps. That will be hopefully a bit easier. So the first step is, how do you define a custom resource and react on the fact that there is an addition or a deletion, just as with a pod. So I've defined here some new type, a new kind. This is not existing within Kubernetes. It is within the Payara.fish, and it's called a domain. And I can give it a name, and I can give some parameters. Let's say that I want my server needs to be based on this Docker image version. I have an application which is called test. So my deployment group, for instance, my cluster will be named test. I will create two instances, but if I would place it there 3, then it should create 3 instances instead of 2. I have some kind of script that's for configuration. Think about the connection to the database, for instance, that needs to be executed at boot time. And I have my application, which I'm expecting at some kind of volume. That's the idea, that you specify here information around your environment that you want to have, ranging from the server until to names, to scripts, and the application, and that everything is set up, the domain, the instances, the load balancer, all the things should be done for you automatically. This is, of course, something new. Domain is not known. So you need, again, another YAML file to define that there is something called a domain within that Payara.fish version. You can use it in within specific namespaces. You need, that's some kind of requirements which I do not entirely understand why, but you need to specify a singular name, plural name, and the name that you give it when you have a list of those things. But just put your basic value domain here and put their list and the S for the plural, etc. And those things will work. So in order to receive this information within Java, we need a Java class, where the YAML file is converted from. So again, I create a class, just a simple Pojo. I annotate it with a few JCON annotations for each one, the PR image, the instances, etc. And then the customer resource itself must extend from a class from the Kubernetes client. I define here that spec variable here. Let's go quickly back here. That spec name is defined here and contains those values and the class that I have here. And for convenience, because I will use it later on, I just print here that I have here the two strings so that you can see what I received from Kubernetes. Again, you need to create a class for a list of those things, just a specific type of an abstract class. And this is also required, from what I understand, to be able to create watchers for it. So again, by convention, just your basic name and adding the extensions here and everything will work. Our Java program is now a bit more complex. Again, we start with getting the client, finding out in which namespace our operator runs, and if you're running within a pod within Kubernetes itself, then it is accessible via a virtual file. So the contents of this file gives me the name of the namespace. So this means that this Java program can no longer run from outside Kubernetes. It must be deployed as another pod within the Kubernetes itself, which makes, of course, sense if it will listen to all changes and perform all the changes required. I need to register that custom kind. I say if I say here to that API, if you find something like a domain with that version, because you have also versioning, please use then this class with all those JCON annotations. And this time I ask the client to look over all the custom resource definitions, finds me the one which I have defined there. And then if it's not found, throw an exception, because if my operator is running in a namespace where that definition is not made, then the operator cannot do very much things. And this, once we have that custom resource definition, we can ask for the client to create, again, some kind of API, some client to work with that custom resource that we have defined in that namespace. Again, we can do the list and watch, listing all the YAML files, not very useful in this case, but the watch is, of course, much more useful. And as you already saw in that previous watch example, you can have multiple events saying that a pod was updated in that case. So we keep the previous version that we have seen, that we have handled in a cache. This is just a map between the unique ID which each document gets assigned and the actual contents of that custom resource. If we, and it sometimes happens that Kubernetes sends us some old information. So if we see that we are currently have already have processed a version number which is more recent than the version that we receive now, then we have nothing to do. Otherwise, if it's an add or a modify action, put that latest information in that cache, because then we can take it from there all the time. If it's a deletion, remove it after we have processed it. And then again, you need to do something. Act upon the fact that Kubernetes informs you that the user has added some YAML file. This is, of course, where the real action starts. This is a bit boilerplate and things that you need to do to properly work with all those custom resources. Quickly going over, because not having that much time. So going over to my second window here. So this is my domain where I've defined my images. So first I have to apply that definition so that Kubernetes knows about it. So apply -f define. I have already defined it previously, so it says it is unchanged. That's good. I forgot to mention, let's have a quick look at the Docker image that I created. And so this is a simple Java program. So I've created an Uber jar, an executable jar file, which contains, for instance, that client. It has a single jar file, and I'm just using a basic Java 8, which I've defined here. Then in deployment where that image is used, so then that image can be used and my operator is working. That's something that I forgot. Sorry about it. So kubectl apply my operator itself. So this creates already a pod for my Java program, which is now watching and for that customer resource. So if we have a look at the log file, kubectl log file, we see that it has detected that it is running in the default namespace, but nothing else because I did not send any value to the API. So let's do this now. Apply f. Not this one. That file with that image, the number of instances, we send it to it. We look again at the log and we see that we have received exactly that same info. That's the toString which is printed out here. And we are coming here at a point where we say, okay, do something with this file, which I will do in the next step. After I've shown a few things what you can do if you receive such a file. So first, remove all the information again, delete the domain and the operator. So that everything is clean again for my next example. This terminating, so it should be okay. At the end, the idea is that we create the domain, the different instances. That instance can only be started when the domain is ready because it needs to know the IP address, etc. So there are a few things that we need to do. So this is the at the point that we are coming to the fact that we received something from Kubernetes and we can create a new deployment. We can define that template. Remember that definition again. We have a deployment template where we will replacing with the time leaf templating engine, where we replace this value here with the value that we have defined in that YAML file, the image that I want to run. So I can process that file. I get a string. I can also ask for the client give me all the deployments which are available in that namespace in the default in our case, and then create me a new deployment. First, we need to upload it to the API server, and then we can ask for an execute. If that is done, we get the message that we have created a new deployment. But we need to do more. We need, besides, where is it here? I'm a bit lost here. Besides the new deployment for the domain that we need to create, we need also create a service for it so that it can be accessed from the outside. And then we wait until the domain is up and running, our server is up and running, and when it is up and running, we can send a few commands to that pod, execute some shell scripts within that pod one. And at the end here, we also add a new deployment model for the node. So it is the same. It's a slightly different template, but again, it's a template which that time-leaf engine will adapt for our case. And executing in the pod here, you have there a specific thing which you need to do, but you find the information about it. You need the output. If you need the output, etc., you can need to watch the pod for a certain pod, the output, etc. And you can execute here with as a bash command, the command that you have executed. And when this watch is, which the countdown latch is finished, so that because everything is asynchronous, then you know that the command is executed and you can return the output of your command, for instance. It's a bit technically already, but the thing is you can do many things. I showed two things here as an example. You can create new deployments, new services, and you can execute shells, script commands within a running pod. And the other one was that based on the IP address, when the IP address was available, here that a live detector, it just detects if there is, if a certain port is up and running, and if that is available, then I can start sending commands to my server. So if we again execute it, now this our program will do a little bit more. Let's see for the output of it. So kubectl, we start our operator first. The operator is best that you start it first. kubectl apply, of course, the Payara operator. The second thing that we apply is the definition of our YAML or our custom YAML file. And then if we look at the log file, we see now that he has done something with that information that we have sent to the operator. He's creating the deployment, the service. After some seconds, the IP was assigned by the system. Once we have that IP, we can start watching if the Payara server is up and running. And at the end, further on, then if it's up and running, we can send those asadmin commands, and we can create again a deployment for the node. And the end result is that you get now 3 pods running, the domain server, and then those 2 instances, which in the next step should receive the application that you want to deploy. To show you that everything is working within Payara, we can have a quick look at the console of Payara. It's not the fastest, of course, because I've limited, as I said, the resources to my system. So I have then my login, and I can look at the deployment group at the cluster that he has created from the moment that he shows me the screen. There it is. I have here the deployment group. I have created that deployment group _ test. The test was the name of the data that we have put in the YAML file, and we see that we have 2 instances linked in that cluster, and that they are both running. And if there was an application deployed, it was ready to serve it to the customer. So that was the more or less complete example. It is not entire finished. The deployment needs to be done, the application and the load balancer. But again, that are the same concepts that I showed you. But we have this was the first proof of concept for the operator that we were writing for the Payara Cloud, which we are launching shortly, which is a platform as a service for your applications running on the Payara microsystem.
I want to know what about mutual exclusion? If you have multiple operator pods, which one reacts on a resource, and how is it avoided that both operator pods are scheduling the same resources for creation if a new resource is added to the cluster?
Yeah, that's something that you have to define with the operator, if I understand your question correctly. So if you upload a certain YAML file, the operator should be able to figure out for which pod or which system it is it should go to. So that's, I did quickly go over to it, did not mention it, I think. But what I did is, if I created the deployment for that domain, I've putting some unique ID. So I've put the unique ID of the YAML file into the deployment metadata. So if I later on receive an update of that that YAML file, I can find out for which deployment it was intended.
The question was a bit different.
Okay, sorry.
You got a Kubernetes operator, which may consist of multiple pods, or is it just always a single pod, this operator instance?
Okay, like that.
How they coordinate their work?
Okay, that's indeed something that I did not try out. What happens if your Kubernetes operator pod is already also scaled? Yeah. That's what you're saying. If you have multiple instances running of that thing, which one gets the information? That's something that I did not try out. So I only created one instance.
Okay, thank you.
Another question from Mario: is my example available on GitHub? It will be, not for the moment, but I will upload it to GitHub together with the slides. It's a new presentation and a new example, so I need to prepare a few things, but it will arrive there, and I will post it on Twitter when it is available. Okay, thank you for joining.